Let's now determine the value of this given limit. That is, we have to determine limit of f of x plus 7 raised to the power of 2 thirds divided by 2 times of g of x and x approaches 0. Using the given limits, that is, limit of f of x, x approaches 0 equals 1, and limit of g of x, x approaches 0 equals negative 1. So therefore, to evaluate these limits, we'll be tracing this quotient law as well as the power law of the limits. So first, I'm going to use this quotient law, which says that limit of quotient of function, that is f of x over g of x, is equal to the quotient of the limits, that is a limit of f of x, x approaches a, divided by limit of g of x, x approaches a. So in the given limit, I'm going to consider this numerator expression as f of x, and the denominator expression, that is 2 times of g of x, as g of x. So when we apply the quotient law, we will get limit of the numerator expression, that is f of x plus 7 raised to the power of 2 thirds, x approaches 0, over limit of 2 times of g of x, x approaches 0. So now we have to evaluate the numerator limit separately as well as the denominator limit separately. So to find the value of the numerator limit, I'm going to use this power law of limits, which says that the limit of f of x raised to the power n when x approaches a, this equals the limit of the f of x, x approaches a, the value raised to the power of n. So let's utilize this. So I can rewrite this expression as, that is the numerator expression can be written as limit of f of x plus 7, x approaches 0, this quantity raised to the power of 2 thirds. Then I put the denominator, that is limit of 2 times of g of x, x approaches 0. Now the next step, we can determine the value of the limits. So for the numerator expression, I'm going to apply the sum rule. So therefore, this will become limit of f of x, x approaches 0, plus limit of 7, x approaches 0, and this whole quantity raised to the power of 2 thirds. And similarly, we can evaluate the denominator limit. We have a limit of 2 times of g of x. 2 is a constant, so using the constant multiple rule, we can factor the 2 out of the limit. So therefore, this becomes 2 times of limit of g of x, x approaches 0. In the next step, we will replace the corresponding limits using the given values. So we are given that the limit of f of x is positive 1 and limit of g of x equals negative 1. So I'm going to utilize these values and replace them over here. So this is limit of f of x is positive 1 and limit of g of x is negative 1. So let me do that. So therefore this becomes 1 plus, we have limit of a constant, 7 is a constant, so limit of a constant is the constant itself, so this becomes 1 plus 7 raised to the power of 2 thirds, and in the denominator we have 2 times of limit of g of x is negative 1, so therefore this becomes 2 times of negative 1. In fact, I replace this as negative 2. We can simplify this. 1 plus 7 is 8, this raised to the power of 2 thirds divided by negative 2, and this gives 8 can be written as 2 raised to the power of 3. So therefore this becomes 2 raised to the power of 3, once again raised to the power of 2 thirds. We know from the exponent laws, these two powers will get multiplied. So therefore 3 times of 2 thirds is, we can cancel the 3, is just 2. So therefore this becomes 2 raised to the power of 2 divided by negative 2. 2 power 2 is 4. So we will have 4 divided by negative 2, and this gives negative 2. So therefore the value of this limit is negative 2. We will now find the first derivative of this expression, that is f of x is given as 2 power x times of cot inverse of x. So let's find the first derivative. The derivative of f of x is written as f prime of x. So here I'm going to use the product rule because 2 power x and cot inverse of x are two different functions. So we can utilize the product rule, which means I have to first find the derivative of 2 power x. So I write down this as d by dx of 2 power x, which is the derivative of 2 power x, multiply with the other expression, that is cot inverse of x, plus then I find the derivative of cot inverse of x, that is cotangent of x, cotangent inverse of x, multiply this with the expression which is 2 power x. So the derivative of 2 power x, we can utilize this formula, that is d by dx of a power x is a power x natural logarithm of a. So here it is in this form where a equal to 2. So when we use this formula, this will be 2 power x natural logarithm of 2. And then multiply this with cotangent inverse, that is cotangent inverse of x, plus we can utilize the formula for derivative of cotangent inverse of x, which is negative 1 over 1 plus x squared. So this becomes negative 1 over 1 plus x squared times of 2 power x. The next step, we can simplify this expression. The first expression remains the same, that is 2 power x natural logarithm of 2 multiplied with cotangent inverse of x. The second expression, we have negative 1 times of 2 power x. So therefore this becomes a negative 2 power x. So we have plus, so we will have finally negative. So therefore this becomes a negative of 2 power x divided by 1 plus x squared. So this is the correct expression or the derivative of the given function f prime of x. So therefore the correct choice is D.